This conference will now be recorded.
Hello everyone. So we will start with chemical properties of acids and bases, and after that we will discuss physical properties, then pH scale, indicator, and if time permits, ionization constant of water. So here we have first the chemical properties of acids. Once we finish this, then we will start chemical properties of bases. So here we have the first reaction, which is very common for acid. So dilute acid like HCl or H2SO4. This type of acid, mineral acid, both react with certain metals. Here it is important to understand certain metals, because all the metals you cannot expect this type of reaction. So only the reactive metals we can expect this type of reactions. So there is release of hydrogen gas. So hydrogen gas will be liberated in this reaction. Okay. So we will see some reactions here. So magnesium metal, which is from S block, when it reacts with H2SO4, it forms MgSO4. That means the sulfate anion of H2SO4 that is now connected with Mg. So Mg here it is in metallic form, but now in the right hand side it is in 2+ state. And the two hydrogens that are removed from H2SO4, that will be released as hydrogen gas. Then another reaction, sodium, which is very active metal, it is from group 1. So when it reacts with H2SO4, now there will be formation of 2Na. 2Na required if you want to balance, because in case of magnesium, it is having oxidation state 2+, and that is balanced by the negative charge over sulfate. So that is by now sodium is having oxidation state +1. So you need 2Na plus to match with the charge of sulfate. So that is by the formula Na2SO4. And just like the previous case, here also hydrogen will be liberated as gas. Now these two are examples, they are with the H2SO4, and remember it should be dilute acid, not concentrated. So another acid, that is HCl, we will now see. Sorry, here it will be HCl, 2HCl. So there will be formation of sodium chloride and hydrogen gas, right? So sodium chloride and hydrogen gas, because 2H plus that is replaced here. Okay, so we have to balance it. It will be 2Na plus 2HCl, and there will be formation of 2NaCl, and two hydrogen atoms together it will make H2 gas, which is the released gas. So these are the three reactions examples of reaction between acid and metal. Now the next type of reaction we will see, reaction with metal oxide. So look at the heading, it is mentioned at metal oxide, in the bracket it is mentioned basic oxide. That means the oxides that are made of metal, they are basic in nature. So that is why it is written as basic oxide. Similarly, when it is non-metallic oxide, it will be acidic oxide. Remember this. So acid reacts with metal oxides and they produce salt and water. Now detailed discussion related to salt, that will be discussed separately, but right now just understand salt is that product which is made when there is formation reaction between acid and base. Okay, so that reaction is also we will discuss under this heading of chemical properties of acid. So salt is that product which we get when there is reaction between acid and base. But in this case, salt is reacting, salt is also produced in this reaction, but now the reaction is not exactly between acid and base, it is between acid and metal oxide. But remember, these metal oxide, they are also basic in nature, right? So as they are basic in nature, so it is a kind of reaction between acid and base. Though these are oxides, so you will not cannot expect any hydroxyl ion OH in this metal oxide. It is simply containing the oxide ion. So acid reacts with metal oxide. We will see some examples. So zinc oxide, that is the metal oxide. It is basic in nature. So when it reacts with H2SO4, there will be formation of ZnSO4. So ZnSO4 is basically the salt. Now this ZnSO4 you can also expect from the reaction between acid and base. Suppose you have taken sodium hydroxide, ZnOH whole 2, zinc hydroxide and H2SO4. then also you will get same type of product. But here we have taken metal oxide. Though it is not containing hydroxyl ion, but because of its metal basic nature, the reaction between these two, it will produce salt and water, just like the reaction between acid and base. So this is the example of reaction between metal oxide and H2SO4. Another acid also we can take ZNO and 2HCl. So in this case, there will be zinc chloride, salt, and H2O. So in the first case, we are getting the salt ZnSO4. In the second case, we are getting zinc chloride. Another reaction we will take with another metal oxide. Suppose it is copper oxide. It is reacting with HCl. And copper here is having 2 plus charge because oxide is 2 negative. Copper can have two types of oxidation state, but here it is 2 plus. There is another oxidation state possibility which is copper plus, but this one is copper 2 plus. So copper chloride is the salt and H2O, that is water, will be produced. Another metal oxide we will take, which is magnesium oxide. The salt is MgCl2. So if you understand one of these reactions, it is not very difficult to write the equation for the other reactions, right? Because it is simply displacement type of reaction where oxide and ion and the H plus ion together is making water, and the metal ion in the metal oxide, which is copper, zinc, or Mg in these examples that we have just seen, that metal ion is reacting with the anionic part of the acid, like sulfate, chloride. Okay, so if you understand one reaction, it is not very difficult to write the other reactions. The third reaction of acid, reaction with metal carbonate or bicarbonate. Now carbonate anion is CO3 2 negative and bicarbonate anion is HCO3 single negative charge. So first of all, we have to understand what is carbonate anion, what is bicarbonate anion, and then there is metal carbonate. Metal carbonate means there will be carbonate anion, it is combined with some metal ion, right? So this is also a type of salt when we are talking about this, but specifically we are having a separate heading for these reactions because this metal carbonate and bicarbonate, there will be release of carbon dioxide gas. Okay, so both metal carbonate and bicarbonate salt, so they are also a type of salt, reacts with acid to release carbon dioxide gas. Okay, and in this case you will also get another kind of salt. So it is true that you are starting with some salt, but you will also get some another type of salt, and the fate of this carbon oxygen, now it will be converted to CO2. So the fate of the anion CO3 minus 2, HCO3 minus, they will be now converted to CO2 and water. Okay. So we will take very common example, calcium carbonate. It is reacting with hydrochloric acid. So this cationic part, that is Ca2 plus, that will be reacting with the negative part of HCl, which is chloride. So there will be formation of CaCl2. Formula you can easily write because calcium is having only one oxidation state. So no confusion, it is always having plus 2 oxidation state. So for one Ca2 plus, you need 2 chloride minus to balance the charge. So the formula is CaCl2, and as we have mentioned here that CO2 gas will be produced, salt will be produced, water will be produced. So salt we have already written, then H2O and CO2. I hope it is balanced. 3 oxygen both sides, yes, it is fine. So this is the first reaction of this type. Then we will write another reaction, FeCO3, ferrous carbonate, Fe2 plus. For iron, two types of oxidation state possible, 2 plus and 3 plus, but here it is, you can understand it is 2 plus. From the formula it is clear. CO3 is having 2 negative charge, and here we have taken only one Fe, so it must have charge 2 plus, right? So FeCO3 plus, let's take another acid, H2SO4. So the sulfate part and the iron part together it will make the new salt, and rest of the part as it is, just like you have already written for it, the first one. Now if you are thinking why not take high bicarbonate, that example we have not seen yet. So let's take NaHCO3. So when NaHCO3 reacting with H2SO4, so again the cationic part is Na, that will react with sulfate and it will form Na2SO4. Now to balance it, 2 sodium as we have already written, so you have to write here 2. And the rest of the part is H2 and CO2, but in this case just check whether it is balanced or not, because in the left hand side you have 4 hydrogens, so it will be 2. Okay, this is also 2, right? 2 carbon. Just check the oxygen. Okay, so this is a third reaction, and the next reaction we will see, it is a salt formation reaction, though we have already seen in the previous reactions how salt is formed, but in this case it is the actual reaction where salts are always produced. Acid reacts with base to produce salt and water. So this type of reaction, it is also known as neutralization reaction, that we will discuss separately in other that is as a separate topic. But remember, these reactions are known as neutralization reaction. Why? Because in this reaction the acidic property of acid and the basic property of it, they neutralize each other's property, chemical properties, and as well as physical properties, and they produce salt and water, right? So here we will see some reactions. Let's take weak acid, CH3COOH, and then we have taken a strong base. Now in this acetic acid, this is the anionic part, that means, and this is the positive part. So K will be now attached with CH3COO minus. So the formula will be potassium salt of acetic acid. You can also write it as potassium acetate, or you can say the molecule as, mention the molecule as potassium acetate or potassium salt of acetic acid, right? So CH3COOK and water. Next, acid HCl and magnesium hydroxide. So here the Mg part and then anionic part Cl, which is in acid, it will produce the salt MgCl2. And here we have 2H plus cation, that is proton, in the acid, and 2 HO. So formation of water molecule, that will also be 2 water molecule. Next we will take a different type of acid, which is HBr. Normally whenever we discuss anything related to acid, we mostly take HCl or H2SO4, but now we have taken HBr. And let's take ammonium hydroxide. So ammonium hydroxide, basically it is generated from ammonia. So when you dissolve ammonia gas, ammonia is actually a gas, but when you dissolve it in water, what happens? When it combines with water, it forms the base NH4OH. It is balanced. See, 1 nitrogen, total 5 hydrogen and 1 oxygen. So it is called ammonium hydroxide. It is always in liquid form because it is basically the aqueous solution of ammonia gas, right? So Br, which is the negative part, and this is the positive part, that is NH4 plus. So it will form the salt ammonium bromide and water, salt plus water. Next reaction we will take barium hydroxide, BaOH whole 2, and so it will produce barium sulfate salt. Formula will be like this because barium is having 2 plus oxidation state. It is from group 2. So 2 plus charge balanced by 2 negative charge and water. 2 water will be there. Okay. So these are the examples for reaction with bases, that is reaction between acid and base. Now we will start chemical properties of bases. The first reaction is reaction with metals. Just in case of acid also you have seen the same thing. So metals like, not all the metals, zinc, tin, aluminium, they react with strong bases like sodium hydroxide, potassium hydroxide, and there is formation of hydrogen gas. We will take aluminium and KOH, and it will form K3Al O2. So this is actually the salt. Sorry, it is O3. So K3, that means total positive charge is 3 plus, because per K there is plus 1 charge. So the negative charge for this anionic part, Basically, in this anionic part, you also have a metal, but overall it is the anionic part. AlO3 3 negative. It is plus hydrogen gas will be liberated. So K3AlO3, it will be 2 K3AlO3 to balance it, and 3 hydrogen gas liberated. Fine. Next is zinc. Sodium hydroxide. It will produce Na2ZnO2. Okay. So one thing is clear. See, here two types of metals are basically present. So one metal which is present in metallic form, that metal now it is in the anionic part. That is, see, here it is metallic form, now it is in the anionic part. Aluminium in the previous reaction, in the right hand side, it is in the anionic part. And in the cationic part, you have the more active metal. It is true that aluminium, potassium both are metal, but if you consider their activity, which is more metallic, which is more strong, it is obvious that is more reactive. It is obviously potassium having more activity than aluminium, sodium having more activity than zinc. So that is why in the cationic part, you can expect potassium to be present. Similarly, sodium should be present in the cationic part because they are more reactive. And the another metal that is now combining with oxygen and it is making the anionic part. So here Na2ZnO2 that you are seeing, total positive charge is 2 plus. That means total negative charge over ZnO2, that will be 2 negative. Okay. So I can just write it here. So ZnO2 2 negative. This is the overall charge. Now see, Zn can have only one oxidation state, which is 2 plus. That means here Zn is having 2 plus state, that is within this bracket. And per oxygen it is 2 negative charge. That means negative charge is total 4. So this 2 plus charge and 4 negative charge, 2 negative charge extra, which is present outside this bracket, and that is why this full species, that is ZnO2, it is having overall 2 negative charge, and that is balanced by 2 Na plus. Similar explanation is also for K3AlO3. Reaction with non-metallic oxide. Now in case of acid, you have seen reaction with metallic oxide, and in the bracket it was mentioned basic oxide, but now it is opposite. Now it is non-metallic oxide, that means it is now basic oxide. So how base will react with non-metallic oxide or basic oxide? They will form, sorry, it is by mistake it is written here. So what will happen, see, we will see some reactions here. NaOH. So we have taken strong base and we have to take some non-metallic oxide. Very good example is carbon dioxide. So here what will produce? There will be formation of salt. In the previous case also we have seen formation of salt, and there will be formation of water. So this CO2, now it will be in the anionic part of the salt. So the salt produced will be Na2CO3. So here the cationic part is sodium and the anionic part is coming from carbon dioxide. Okay. And there is water. So sodium carbonate and water. This is the example. Reaction with salt. Base can react with certain salt to form another type of salt and another base. So this is very interesting. In the left hand side also you have taken some base and you are reacting it with some salt. In the right hand side also, as a product, you are getting another salt and another base. Now, if you are thinking which side the reaction should actually occur, because if you are thinking from the product side, that reaction is also possible. Both side there is salt plus base. So that side the reaction you can expect where more reactive salt and base are present. So now we will see the example, then it will be clear to you. 6NH4OH and aluminium sulfate. This is our salt, Al2SO4 whole 3. So these two when react together, we are getting 2AlOH whole 3. Now this is another base, that is in the product side you are getting another base, and there will be formation of ammonium sulfate. So this is a salt, left hand side, This is another salt right hand side. So this base, which is hydroxyl carrying some hydroxyl ion, this is also base carrying some hydroxyl ion. So NH4OH must be more reactive than this, and that is why the reaction is happening from left hand side to right hand side. Right? One more example, ammonium chloride. Now this is the salt and NaOH. So this is salt, this is base. Now NH4, it will take this anionic part. So you are getting a new base and Na and Cl together. So this is the salt. So see, same thing, same logic you can apply here. You have started from one type of salt, you are getting another type of salt. You have started from one base, you are getting another base. Now we already know that sodium hydroxide is much stronger than ammonium hydroxide. So that is why that opposite reaction you cannot expect. If you mix NaCl with NH4H, you cannot expect that NaOH will be generated, NH4Cl will be generated. No, that will not happen, because NaOH, which is more reactive than NH4OH, so how it will be generated from the less reactive reactor? Okay, so that is why the reaction should be like this. In the left hand side, you have to write NaOH and NH4Cl. So now we have completed the chemical properties of acid and bases. Next, we will see the physical properties of acid and bases. Right? Basically, here acid, base, both we have taken, not just base. So first, it will be the discussion for acids. Physical properties of acid. So being corrosive in nature, they are corrosive in nature. So when you have some strong acid, they can spoil substances like human skin, clothes, paper. And that is why whenever we are working in the laboratory, we are handling acid, we should wear gloves. Okay? Especially if it is concentrated. Generally, they exist in liquid state, but few acid can exist in solid state. And most of the time, the examples of solid acid that you will see, they are mostly from organic type of acids. Inorganic acids mostly they are in liquid form. Now, if you are thinking that HCl, sometimes it is written physical state as G, sometimes it is written as aqueous. That is, aqueous means it is obviously in water, but sometimes HCl that you see in the laboratory in the that is a glass bottle, and it is in liquid form. So when the HCl gaseous form it is mixed with water, its aqueous solution is basically kept in laboratory in the bottle. Okay. So physical state G, L or aqueous, all the possibilities are there. Most of the time they are colorless and they change the color of indicator. Now indicator will be discussed separately as a separate topic, but remember they are those substances which helps us to understand whether a solution is neutral, acidic or basic. That is the simplest way I can say I can define indicators. Okay. And how they do so? By changing the color. So suppose you have an indicator and you have unknown solution, you do not know whether it is acid or base, and the indicator is having some specific color. So you just what you do, you just add some indicator, very little amount, and from the color change you can understand the unknown solution that you have, that is acidic or basic. That answer you can give. Then they are soluble in water, and solutions of acids conduct electricity due to ionization in water. So just take HCl for example. When you take it in water, there is formation of H plus, and this H plus it doesn't remain as H plus form. It combined with water and ultimately it forms, that is, it is equivalent to hydronium ion. That means it is combining with water molecule. So what I'm trying to say here, the ions are generated from neutral molecule, ions are generated, and ions, without ions electricity conduction is not possible. There must be some charged particle, then only electricity conduct all these things. This question arises. So solution of acid, they can conduct electricity because of this type of ionization. Suppose you have taken HCl in water and there is no ionization, then there is no H2O plus, no OH minus, then how you can expect electricity? So there is formation of cation and anion, and that is why it is conducting electricity. Okay, so these are the physical properties of acid. Then we will see the same for bases. Bases generally exist in solid state. Now unlike acid, mostly you will see it in a liquid form, but the most common bases that we mostly discuss NaOH, KOH, they are in solid form, available, right? In laboratory, if you have some experience, you will see they are available in solid form. Though there are some bases, though that is two or one example you will always get, that is ammonium hydroxide, because ammonium hydroxide is the ammonia and water together, it makes ammonium hydroxide. So obviously it has to be in liquid form, it cannot be in the solid form. You cannot say NH4OH, it is in solid form. It is not possible because it is the aqueous solution of ammonia gas, right? Bases give soapy touch only in aqueous medium, not in dry nature. Okay, there is a soapy type of feeling, slippery type of feeling. They are bitter in taste, but obviously you shouldn't try it. If you have some mild base or you are eating some food that is mildly basic in nature, you can understand this fact. But don't try it in the laboratory, right? I hope you can understand it. Then being corrosive in nature, when come in contact with skin frequently, they form painful blisters. So with base also, it is better you always wear gloves. Colorless, just like acid, they also change the color of bases. So just like acid, here also this change, that is color change, occurs because indicators they are having specific color in basic substance and acidic substance. Then base also conduct electricity, and it is for the same reason, right? It is for the same reason they can conduct electricity, just like I have said that there is generation of cation or anion. So suppose you have taken KOH and you have aqueous solution of KOH, there is formation of cation K plus and OH minus. So that is why they will conduct electricity. So these are the physical properties of acid and bases. Now, uses of acids and bases. First, you will see the uses of acids. Here you can see the name of some in bold for some common acids that we have discussed. Though there are some acid that is they are biologically important. Detailed structure we obviously don't need, but here this information is very important. That cells of all living organism, they contain this fundamental nuclear material, which is nucleic acids. So animals have DNA, the full name is deoxyribonucleic acid, and for plants it is RNA ribonucleic acid. Just this fact is this much is enough. Then come to the other acids that we already know. Hydrochloric acid present in our stomach naturally, and it helps in the digestion of food materials. And also if there is some slight any undesired things are present by mistake, if we ate something, the acid also destroy to helps to destroy those undesired things, right? Then vinegar or acetic acid, we know we use it to preserve food materials, and sometimes in cooking also there is some use. Benzoic acid, it is organic acid, that is benzene ring, and with it there is CO2H group, or benzene ring, it is written as PHCOOH. PH means the benzene, this part is pH. Sulfuric acid is an effective dehydrating agent. Sulfuric acid, it is known as king of chemicals. Why it is known like this? Because this acid is such an acid which can react with so many variety of substances. Its reacting capacity is so high. So that is, it is called king of chemicals, and it is a very good dehydrating agent. It has the capacity to attract water. Then it is used in various industries to make detergents, paints, fertilizers, many more chemicals. So these are the applications. Hydrochloric acid, nitric acid, HNO3, and H2SO4 sulfuric acid, they are also important laboratory reagents. In any laboratory, the basic, there are some basic chemicals that are always present, even if the laboratory is very simple and that is for lower, that is low grade, not very high grade. Then also you will always see this type of acid, they are always present in any laboratory. Now come to this one, sodium and potassium salt of higher fatty acid. Now fatty acid means, it is basically discussed in organic chemistry. Fatty acid in general, I can write it in this way, RCOOH, where carboxylic acid group CO2H is present. Now this R part is containing very long chain of carbon and hydrogen. So details I am not going, just remember fatty acid means there will be a CO2H group and there will be a long chain of carbon and hydrogen. But we are talking about the salt. Suppose this H, when it is replaced by sodium or potassium, we will call it sodium salt of higher fatty acid. Higher means this chain is very long, that is why. So the sodium salt of this fatty acid, they are used in washing or bathing soap. Next, uses for base. Potassium hydroxide, it is used to make bathing soap, because see here we have just talked about it. So here when you are trying to make this salt, it is sodium or potassium salt of higher fatty acid. So there is use of KOH, right? So when this acid is mixed with KOH, that is acid base reaction, and there is formation of salt, and that salt is this salt, sodium or potassium salt of higher fatty acid. That means KOH is also required to make this salt. So that is also the application. Then sodium hydroxide, NaOH, is used to make washing soaps, and in paper industry, textile industry, in preparation of medicines. Calcium hydroxide, CaOH hold, for whitewashing. Aluminium hydroxide, that is AlOH whole 3, because their oxidation state for aluminum is 3 plus, so that is why 3 OH required. And magnesium hydroxide, the formula MgOH whole 2, because magnesium is 2 plus charge. They are used in antacids to cure acidity problem. As we know, the first point here, HCl is present in the stomach. Sometimes because of wrong food habit, there may be excess of acid generation, and then we use this antacid, which can neutralize excess acid. Then ammonium hydroxide, that is the aqueous solution of ammonia gas, is used to manufacture fertilizers, nylon, plastic, rubber. So these are the applications of acids and bases. Next topic is pH scale. Now this is something new, pH. But before going to this, we have to understand dilution. We have already talked about this fact in the chemical properties of acid and bases, that remember the reaction between acid and metal, there we have mentioned that it is dilute acid, that you take some dilute HCl or H2SO4, you react with sodium, magnesium. So this dilution means you are decreasing the strength of acid or base. So suppose there is 1 ml of HCl and you are adding 9 ml of water, and the total volume is now 10 ml. So what you have done? You have done some dilution of the original acid. So dilution is the process of decreasing the strength of acid or base. So acid or base, we know that they produce this type of ions, proton and or hydrogen and OH minus, right? Now when they are diluted, that means you are adding more amount of water. So what will happen? The concentration of H plus and HO minus, that will decrease. Remember, concentration, there are so many ways you can express. In the previous unit also we have seen. Suppose just take the example of molarity. Molarity means moles per unit liter. How many moles present in 1 liter? So when you are diluting, obviously the number of H plus per liter, that will decrease. Okay, so that is why you can say the concentration of these ions will decrease. And this results in decrease in the strength of acid or base. Now, how it is related to pH scale? Because pH scale will give you the idea that whether a particular solution it is acidic or basic. And even if it is acidic, suppose you know that it is acidic, but is it very strongly acidic or moderate acidic or very weakly acidic? That idea also you can get from pH scale, right? And that is related to dilution, because dilution means you have some strong acid or base, and now with adding water, you are making some dilute solution. And the dilute solution that you have made, if you add again some more water, then you will have more dilute solution. So gradually the H plus concentration or OH concentration, depending on you have started with acid or base, both are decreasing. And this has some relation with pH scale. So let's talk about now pH scale. So pH scale is a scale. It is used to measure the strength of acid or base in a solution. And it is actually known as pH scale. So what this P is? The P in this pH stands for potence in German, which means power. Okay. And the H, capital H in the term pH, it stands for hydrogen ion. So what it means together? It means the power of hydrogen ion. So when power of hydrogen ion high, there will be in the scale there will be one type of value, and then when power of hydrogen ion is low, there will be another type of value in the pH scale. Okay. Now this acidity or basicity, it is usually expressed in terms of function of H plus ion concentration. So what it means to say, suppose you have a solution and I'm asking you what is the acidity of it. So obviously you will answer it in terms of H plus ion concentration. Similarly, if I ask you what is the concentration of, uh, suppose you have taken some base solution and I'm asking you what is the concentration, what is the basicity of your solution. Is it very strongly basic or is it weakly basic? Tell me. So then the answer that you will get, that answer also you can give me in terms of H plus ion concentration. Now if you are thinking that it is basic solution, then how can I say it in terms of H plus ion? But the matter is relative thing. It is possible to answer in terms of H plus ion. That is the normal convention we follow. Whether your solution is acidic or basic, irrespective of that, you can always answer the question that what is the strength of this acidic or basic. You can always answer it in terms of H plus. So even if your solution is basic, you can answer it in terms of H plus ion. And why it is possible? Because when basicity is high, that means H plus ion is very low. So that is also another indication that your solution is basic in nature. And this acidity basicity, it is all happening in the aqueous solution. And in aqueous solution, we talk about only hydronium ion, NOH minus, right? So whether it is basic solution or acidic solution, these two ions will always be present. Then what is the difference? The difference is if the solution is acidic, H2O plus will be predominating. And if it is basic, the reverse. So you can always express it in terms of the function of H plus ion concentration. And that is actually the pH of the solution. It is always expressed in terms of power of hydrogen. Now pH should be thought of simply as a number. So when we will next see what is pH, it is basically ranging from 0 to 14. So when it is 0, that is one terminal, it means very acidic. It is reverse. Don't think that it's power of concentration. So when pH will be high, then acidity is high. No, it is not like that. It is reverse. When pH is minimum, and the minimum in the scale is basically ranging from 0 to 14. So when it is 0, then it is strongly acidic. And when it is 14, it is very alkaline, okay, or basic. Now, one more thing, it is important to know that alkaline and basic, there is a difference between these two. Base is basically very general term. So when I say base, that is all bases cannot be alkali, but all alkalis are basically base. So base is broader term and alkali is a narrow term. Only certain bases that are soluble in water, that is water solubility is present, you can call them alkali. And mostly when we talk about alkali, it is KOH, NOH, because these are the bases we mostly handle with. That is most of the problems or whatever you are studying anywhere, any book, you will see these two bases always. Okay. So only those bases, because some bases, some organic bases may be there which are not soluble in water. So you can call them alkali. Alkali will be only those bases that has some water solubility, very good water solubility. So we can use both the terms interchangeably. Sometimes it may be written as basic, sometimes it may be written as alkaline, because both terms are fine. And because we are handling NaOH, KOH. So pH, when it is 0, it is one terminal, one extreme, it is very acidic, another extreme is 14, it is very alkaline or basic. So higher is the H plus ion concentration, which is expressed in this way, H plus within third bracket. It means concentration of H plus. You don't have to write the word separately, concentration. When you are writing it like this, H plus within third bracket, it itself means it is hydrogen ion concentration. So when this value is very high, that is hydrogen ion concentration is very high, then lower will be the value of pH scale. And that is already mentioned here. When pH is close to 0, then H plus concentration is very high. That means it is very acidic. So it is a reverse relationship. Okay. So the pH of aqueous solution, how it is related to H plus, it is related by this relation. pH is negative logarithm of H plus ion concentration. So suppose you know the H plus, first of all you take its log value, and then mostly it will be negative, and this negative will be cancelled. Ultimately we'll get positive value. And pH, we know it is integer, that is a number, not always the integer. It may be 4.3, 5.6, that is also possible. Similar, just like pH, you can also calculate pOH, and that is negative logarithm of OH minus ion concentration, just like H plus. So there is both pH and pOH, but mostly we talk about pH. When pH is very high, pOH will be very low, and it has to be, because H plus and OH minus, these two, or you can say H3O plus and OH minus, these two cation and anion, they are always present in water. So when one is increasing, another has to fall, and vice versa. So here we have this scale, and you can see the examples of so many things that you already know in our day-to-day life. It is not something new. So this is one extreme, which is acidic. This is another extreme, which is basic or alkaline, right? So here battery is mentioned. That means inside the battery, that is rechargeable battery, you can take the example of inverter. There is very high concentration of H2SO, so it is highly acidic. Then stomach acid, that is also very acidic, HCl. Then lemon, vinegar. In vinegar, what we have? We have acetic acid, and acetic acid is not so strong like HCl and H2SO. It is obviously in acidic side, because up to this point 0 to 7, it is the acidic zone. Now within acidic zone there is also higher zone and lower zone. Higher zone is 6, higher zone is 0 1, and the middle part is 3 4, and the another extreme is that is, it is going towards neutral. That is, within this also I am just breaking it in 3 parts: this reddish part, then yellowish part, and this greenish part. And when you reach 7, now it is neutral. Water is neutral. Okay. Then we have blood. It is slightly basic in nature. We have baking soda, which is mostly containing NaCO3, and that we use in cooking also sometimes. Stomach tablet, it is basically the antacid it is talking about. Remember, when there is excess acid in our stomach by mistake, by wrong food habit, spicy food, this excess acid can be neutralized by MgOH whole 2, and that is available in form of tablet or liquid, and it is known as milk of magnesia. Then bathing soap or detergent, ammonia solution, look at this, it is 11. Then drain cleaner, it is very strong basic. When we use some drain cleaner to remove the blockage in the sink or basin, then it is very strongly basic. And then bleach, that is also strongly basic, right? So remember this, for acidic pH value must be less than 7, alkaline it is reverse, and for neutral it has to be exactly 7, right? So next we'll see the application or role of pH in our everyday life. So existence of living beings. Organism require a specific pH for their ideal growth and development. So inside our body or in the body of animals, so many things are going on. So many reactions are going on. Complex reactions are going on always. And without those reactions, we cannot survive, right? And those reactions inside the cell, that requires a particular pH. For example, in human body, all physiological actions, they take place in this range. It is slightly close to neutral, slightly towards basic. So the existence of aquatic plants, animals, microbes, they are actually at risk when there is acid rain mixed with the natural water body. So in the natural water body, the aquatic plants that are present, animals, water dependent, microbes, they will be, that is, their survival will be harm, there will be bad effect because of this acid rain. So pH, next point and role of pH is in our digestive system. As we have mentioned, there is HCl produced in our stomach that helps in the digestion of food. And the system is such that the stomach lining is such that stomach itself, there is no harm for this acid. The inside the lining that is present, it can sustain. Otherwise, how we can survive? So the system is such. But if this amount of acid is above a certain range because of indigestion or eating spicy food, then pain and irritation can occur. And that is why, as a remedy, we can uh, take some mild base, and they are called antacid magnesium hydroxide MgOH2, and that is also available in the market in the form of, that is, some liquid, or it may be in tablet also, milk of magnesia. The liquid form is milk of magnesia. So these are taken to neutralize this excess acid. Self-defense by animals and plants through chemical warfare. So you all of you have this experience. When we inserts an acid through its sting, we have feel pain and irritation. Now there is some acidic substance. This honeybee, they are actually doing this for their self-defense, right? As if when they feel threatened, they do so. Now, this pain and irritation is occurring because of some acidic substance, and so we have to apply some mild base if we want to get recovery. So, mild base like baking soda, which is always available at our home, we can apply it to treat the wound. Similarly, nettle leaves, a special type of leaves, they have stinging hairs. So, if you by chance touch these leaves, the same type of feeling occurs, and that happens because of this formic acid in our body when touched, that is inserted. Formic acid is ACOOH, carboxylic acid, it is organic acid, and there is a burning sensation. So this happens because of their natural self-defense. And if we apply some mild base, we can get recovered. pH change in soil. So this point is important for agriculture. The pH of soil, it is a critical factor if we want proper growth of crops and other plants. So this is the range which is should be maintained. Okay, it is close to neutral, that is close to 7. It is ideal for the growth of these shrubs and crops. If pH of soil is less than 6.5, it can be because of acid rain, so many other natural process. If we throw something which is chemicals, which is acidic in nature, then also pH of the soil can be ranging towards acidic. Then lime is added. That is, calcium oxide is added, which is called lime, to neutralize its acidity. Okay. Similarly, if the pH of the soil is greater than 7.3, gypsum is added to neutralize its basicity. pH change leads to tooth decay. When we eat some sugar content food, it breaks down by bacteria present in the mouth, and there is formation of acid. It may be for some other food also. Now, when the pH of the mouth, it becomes lesser than 5.5, then what happens? The tooth enamel, which is nothing but calcium phosphate, it gets corroded. So there is true decay, right? Now, saliva, it is slightly alkaline in nature. It is produced in the mouth. It can do this neutralization to some extent, but still it is not enough. If it is excessive, if we, after eating high sugary content food, if we are not washing our mouth, it can cause tooth decay, right? So this excess acid we can remove if we use some alkaline nature toothpaste or neem stick, which is very good, naturally available. It is containing some alkaline juice. It is, if we brush it with neem stick, then also it is very good for our tooth, health of tooth. And it is also because of this alkaline juice present in it, which can neutralize this acidic uh, acidity increase by because of this wrong food. Actually, not the wrong food, that is, after eating those foods we should wash our mouth. Okay, now we will start indicators. So indicators, as the name suggests, it will tell us, it will give the indication whether a substance is acidic, basic, or uh, neutral in nature. And how they can do so, they can change their color. So from the change, from the visual change, we can understand the nature of the solution. So here we have this table, that is types of indicator, total 3 types of indicators: natural, synthetic, olfactory. So natural indicators, they are basically, their origin is some plants. Okay. Then synthetic indicator, that we can make, we can synthesize in the laboratory for some, from some chemicals. And olfactory indicator. It is related to smell. So we will come to one by one to all these indicators with proper examples. So natural indicator, the first one. This is the number 1, 2, this 3, total 3 types. So these are, as the name suggests, from natural sources, and very good example is litmus. So whenever we talk about acid base, if we do not talk about litmus, then it is not complete. So very common indicator, litmus, the source is some plant. Then turmeric, red cabbage, there is a purple color cabbage, I hope you have seen it. China rose, etc. They are the common natural indicators used widely to understand acidic or basic nature. So litmus, how it does the work? The solution of litmus obtained from lichens type of plants. It is purple in color, that is itself the color is purple. But litmus papers are made. There is a special kind of paper where litmus, that substance is present. They comes in two variety. Two different types of litmus papers are available, blue and red. So these two helps us to understand whether a solution is acidic or basic. So blue paper is used. Suppose you have some solution which is acidic, and if you are dipping some blue litmus paper, it will be converted to red. And the opposite is for red. If you dip the red paper, red litmus paper to some basic solution, it will be converted to blue. But if you are dipping the red litmus paper in acid, there will be obviously no change, because from blue it will be red. But if it is already red, there is no question of change of color. Then turmeric. Now turmeric solution is household. We have the idea. Turmeric solution or paper turns reddish brown with base. So there is turmeric paper that is also available, but better to talk about turmeric powder or solution that you can easily make at home. You can easily do this taste also. Suppose sometimes there is a in our cloth, if some turmeric, that is curry, is by chance if it falls, there is some yellowish mark, right? Yellowish brown mark. And then if you try to wash it with some detergent, you will see that mark is converted to, because in detergent there is some basic substance. So that will be converted to some reddish color. So turmeric, the yellow color, if you take some in some acidic solution, there is no change. But when you try to wash your cloth where some curry mark which is containing the turmeric powder, and you are trying to wash it with detergent, you will see it will be changed the color to red. That test you can easily do at home. Then red cabbage, the juice of red cabbage, it is purple in color. Now the juice of red cabbage, better you can call it purple cabbage, because when you actually see it, it is purple in color, not red. So juice of red cabbage, it turns reddish in color if it is in some acidic solution, but greenish if it is some basic solution. So here we have different types of indicators in this table. So let's talk about this red cabbage water. So red cabbage water, when it is in acidic, that is pH is 7, the color is red pink, and at neutral it is purple, which is its original color, and in basic gradually it is changing blue, green, and if it is very basic then it is yellow. Then red onion powder, red onion water. Now these also red, violet and green. But mostly when we talk about onion, that will be discussed in olfactory, or through smell, not through color. It is all about the through smell we can understand. So though it is written here, you can consider it under this natural category, but onion example we will see mostly in olfactory indicator type, number 3. Then turmeric water, yellow, yellow. In acidic there is no change. Original color is also yellow, but in base it will be red. Now phenolphthalein and bromothymol blue, these two are basically synthetic. But from this table you can understand how it will change its color. Phenolphthalein, it is itself is colorless, only changes color in the basic solution. Then bromothymol blue, 3 different color. Originally it is, that is a neutral condition, it is green, but yellow and blue in acidic or basic respectively. Then red litmus and blue litmus. This we have, I have already mentioned. So the red litmus paper, if you take In acid, it is already red, so there will be no change, but it will be blue here. And the blue litmus, which is mostly used to understand whether it is acidic solution or not, it will change its color to red. And in basic, there is no question of changing color. And there is another substance which is universal indicator. Now this is very useful because you don't have to depend on any indicator. These papers, they can show different color, not just in acidic. So what happens? In acidic also there are some range. Suppose 0 to 2 one type of range, then 3 to 4 another range, then 4 to 7 another range. So that also you can understand very subtle way. That is, when it is red, there is, you can understand that it is not will give you the information that it is acidic, but how strong acidic, that, and that also you can understand if you have some universal indicator. Okay, so red, orange, yellow, and then blue, violet, and gradually close towards the maximum pH, which is 14, it will be part. So here we have seen what is natural in and in this India basically so many things are mixed and details not required. Just remember universal indicator will give you some extra detailed information. Then synthetic indicator, as the name suggests, they will be synthesized in the laboratory, and examples are phenolphthalein, you have already seen in the previous table. There is one more example which is not present in the table, which is methyl orange. It is originally orange in color, which you can remember from the name itself, but it becomes red in acid, yellow in base. And the last type, which is, this is number 3, this is number 4, substance which change their smell. Now these type of indicators are very good for those people who are visually impaired, who cannot see the color, right? Now this type of indicator will help us to understand whether a particular substance is acidic or base, because these indicators, they can change their that is the smell that you will get, it will change. So examples here we will see onion, vanilla, clove oil. So when it acidic solution and you have mixed these indicators, same smell you will get, just like the original smell of onion. Here also remains same, here also remains same. But when it is basic, it loses its smell, and also true for the other. So for all these three, we know there is a strong smell for all these three. And if it is basic, then it will change its smell. Okay, so this is good for visually impaired people. So that is all about the indicators. Here we will have one question. We have some time, we can discuss it. You are given 3 solutions A, B, C. So this is A solution, this is B solution, this is C solution. Write which solution has more hydrogen ion concentration among the 3 and state the nature, acidic or basic. So it is A. It is pH, having pH 2, then B is 10 and it is 30. Now if its pH is 2, that means what? The negative logarithm of H plus ion, that is actually 2. Now if you want to know what is H plus ion concentration, what you have to do? First of all, you have to bring the negative side towards 2. So it will be minus 2. And here as the base is 10, it will be 10 to the power minus 2. And the same thing you can also write for B. So here H plus ion concentration will be 10 to the power minus 10. Here it will be 10 to the power minus 30. Now this is the maximum value, right? Though from pH itself you can understand that which solution has more hydrogen ion concentration, it is obviously the A solution, the first solution. But why it is so? I am just breaking this equation, minus log H plus equal to 2. So how you can understand what is H plus? It will be 10 to the power minus 2. So in general, I can write it like this. From this equation directly, that H plus will be 10 to the power minus pH. So why this equation is important? Suppose pH value is given and the question is asking you to find out H plus concentration. Then this equation will help you. And if pH is not known, H plus ion concentration you know, then you can use this equation. So both the equations, and here you have to mention whether it is acidic or basic. So this is obviously acidic, this is basic, this is also basic, because these two are greater than 7, so they will be basic. So we'll end the discussion here. We are at the end of the session. Thank you for listening.